In this video, we're going to talk about solving systems of linear equations in two variables using the addition or elimination method. All right, so let's solve this system. Well, let's add the two equations together. X plus x is 2x. Y plus a negative y is 0. And 6 plus 2 is 8. Divide both sides by 2, and x is equal to 4. Now, let's go back to the top equation, replace x with 4 to solve for y. Subtract the 4, and y is 2. Check the bottom equation, and that's easy to tell that that works. The solution here is 4, 2. So, why does this work? Well, let's take a look at the coefficients for y. This one is 1, and this coefficient is negative 1. So when I add opposites together, I get 0. So the method that was used here is what is called the addition or elimination method. To solve a system of linear equations using the addition or elimination method, we want to rewrite each equation in the form of ax plus by is equal to c, which is standard form. Create a new system with opposites as coefficients on one of the variables, if necessary, by multiplying one or both equations by a non-zero number. Add the equations, solve the equation, substitute the value found in step 4 to calculate the other variable value, and then check your solution. So let's solve the following systems using the addition or elimination method. Now, for this system, I'm going to choose to eliminate x. So I'm going to rewrite. Now, I need to determine what the least common multiple of the numbers in front of the x is going to be. Well, this is 1, this is 5, so that least common multiple is 5. But remember, one of the coefficients has to be 5, the other one has to be negative 5. So I'm going to multiply the top equation by negative 5 and multiply. Rewrite the second equation. Now, add the two equations. Negative 5x plus 5x is 0. Negative 20y plus 3y, that's negative 17y. And negative 70 plus 2 is negative 68. Divide both sides by negative 17, and y is equal to 4. All right, I'm going to replace y with 4 in the top equation to calculate what x is. 4 times 4 is 16. Subtract the 16. X is negative 2. Now, let's replace x with negative 2 and y with 4 to see if it works for the bottom equation. And in this case, it does. So my solution to the system is negative 2, 4. Okay, let's take a look at the next example. Notice neither of these equations are in standard form. So let's do that first. I'm going to add 5y to the top equation. And I'm going to add 4y to both sides on the bottom equation. Now, this time I'm going to eliminate y. But you certainly can eliminate x, and if done correctly, you should get the same answer I do. So the least common multiple between 5 and 4 is 20. Remember, one of the coefficients has to be 20. The other one has to be negative 20. So I'm going to multiply the top by 4 and the bottom by negative 5. So multiply. So 12x plus a negative 25x is negative 13x. 20y plus a negative 20y is 0. And 28 plus 50 is 78. Divide both sides by negative 13. That gives you x equal to negative 6. I'm going to plug it back into the top so I can solve the equation for y. That's negative 18. Subtract the 7. And then divide both sides by -5. So now I'm going to replace x with -6 in the bottom equation and also y for 5. That's a true statement. So -6, 5 is a solution to this system. Okay, let's take a look at the next example then. So again, I'm going to choose to eliminate x's in this particular case. So let me rewrite. Okay, so I'm not going to worry about the negative. The coefficient here is 1 and 3. So the least common multiple of 1 and 3 is 3. I've already got this to be 3, so I'm going to multiply the top by 3. So notice what happens here. Negative 3x plus 3x is 0. 15y plus a negative 15y is 0. So I've got 0 on the left, and negative 3 plus 3 is 0 on the other side. So what does that mean? This means I have infinitely many solutions. Okay, one example left. So again, I need to rewrite the bottom equation in standard form. I'm going to add 6y to both sides. All right, so I'm going to eliminate y here. So the least common multiple between 3 and 6 is 6. Again, one coefficient has to be 6. The other one has to be -6. Since I've already got this to be 6, I'm going to multiply the top by -2. Rewrite the second equation. So, notice what we have. Negative 4x plus 4x is 0. Negative 6y plus 6y is 0. So I've got 0 on the left. Yeah, but I don't have 0 on the right-hand side. I have 3. So what does that tell me? I have no solution here. And because I have no solution for this, I know that the graph of this would be two parallel lines. The previous example with infinitely many solutions, I know that these two equations would graph to be the same line.